Hi, this lesson we will look at statistic 2, the distributions of sample means. So the distribution of sample means from a normal population, right? Point 1, if you take many samples and calculate the mean of each sample, these means have a distribution called the distribution of the sample mean. A sample mean, x bar, can be regarded as a random variable. Okay, point 2, if x1, x2 until xn is a random sample of size n taken from a normal distribution with mean of mu and variance sigma square, so such that this, then the distributions of x bar is also normal and it follows a normal distribution with the same mean, the mu, but the variance, can you see the sigma square, will be divided by the sample size. Okay, where your x bar, as we mentioned, is the sample mean, and taking all the samples, sum up divided by the sample size. Now, let's look at an example here. So x is the median apple weight, and x follows a normal distribution. That means if you weigh this medium-sized apple, it has 180 grams as the mean, and the standard deviation is 5. So 5 square as the variance. All right. So now we take a sample of 4 apples, 4 medium-sized apples. All right, we weigh them and we try to look for the mean of these 4 apples. So isn't it, we are taking the x1, x2, x3 plus x4 and divided by 4, right? That is how we get the mean. And let's say the value found to be 182 grams. Now I'm taking another sample of 4 apples, another 4 medium-sized apple, and look for the mean of these 4 apples. I'm getting x bar 2. And let's say the value happens to be 180. The mean weight of these 4 apples is 180 grams. One more sample of these 4, another 4 random sample of the apples, and I'm getting the third mean value, x bar 3. And let's say the value calculated to be 178. So can you see? X bar can be regarded as a random variable because the values x bar is varying. Okay. We have a random sample of 4 apples. Then the mean of these 4 apples, the mean weight of these 4 apples can be 182, can be 180, or can be even 178. So it is varying and it can be regarded as a random variable. So when you are given from second point here, when you're given that the x, the median apple weight, is a normal distribution, hence the mean weight as a random variable, it also follow normal distributions where the mean will be exactly same as 180, right? This one, the mu, these are same, but the variance has to be divided by the sample size. So as I'm taking a sample of 4 apples, so hence the sample size is 4. Okay, so that will be the sample mean distributions. Okay, now we are going to look at we're going to look at the past year question as example, right? To find the probability if you are going to have to find the mean weight, right? The mean of the sample. So this is the question from 71 variance, October, November 2009, question 3. So the weight of the pebbles on the beach are normally distributed with mean 48.5 grams and standard deviation 12.4 grams. Okay, based on the information given so far, let's say X is the weight of the pebbles. It follows normal distributions, where the mean is 48.5 and standard deviation given to be 12.4 and square as the variance. Okay, answering part 1. To find the probability that the mean weight. So when the questions emphasize the mean weight, means we are looking for the sample mean, right? The mean weight of a random sample of 5 pebbles is greater than 51 grams. So which means we are going to find the sample mean distributions. As given that the weight of pebbles is a normal distribution, hence the mean weight of the pebbles is going to be normal distributions, where the mean is 48.5 and the variance is going to be 12.4 square divided by the sample size, a random sample of 5 pebbles. So divided by 5, right? And then we are trying to find the probability that the X bar, right, the mean weight of a random sample of 5 pebbles is greater than 51 gram, right? So now we are going to use this sample mean distribution. And since it is a normal distribution, in order to find out the probability, we got to perform standardizations. So which means we are going to take this value, 51 minus the mu divided by the standard deviations. So can you see this value, the whole thing is the variance sigma square, or I just put it in sentence, the variance. So the variance is this. If I'm going to look for the standard deviations, I'm supposed to square root this. Okay, so that's why we are getting 12.4 square. All right, so that is the standardizations. Now try to find out the value of this z-score. Keep to 3 decimal places. Short by 4 square divided by 5, square root it, and taking 51 minus 48.5 divided by this value. So the z-score is going to be 0.4508, so 0.451. Now we are going to refer to the normal distribution table in order to determine the probability. The z-score and exactly the middle must be 0. A z-score value greater than 0.451, right? We are looking for this area. As we know that according to the distribution table given to us, the area which is the probability given is going to be the value all the way to the left. Hence, we are going to take 1 minus, right, to find out the answer. Okay, let's see an extract of the normal distribution table here. When the z-score is 0.4, okay, this column and this row, 0.4 is here, and 5, right, 5, and then the last is 1. Okay, what is the intersections here? 0.6736 and 4. So which means the 4 here is the last digit of 0.6736. So we are looking at 6736, 0.0004. So what are we getting? 0.6740. So 0.6740 is the probability, but the table will give you the bigger region here. So this is the region given, which is the probability is 0.6740. So that is why in order to look for the smaller region towards the right, we take 1 minus. And that is the probability. 0.326. Right? Keep the answer to 3 significant figures. Found the probability for part 1. So how do we know? We have to use the sample mean distributions. Right? Look at the keyword. When the question asks for the mean. So for this example, is the mean weight. It can be the mean height or the sample mean. All right. Find the probability of the sample mean. Find the probability of the mean weight. Find the probability of the mean height. So whenever the question asks for the keyword mean or the sample mean, then you know we are looking at sample mean distributions. And it is a normal distribution we discuss here. So we got to perform standardization and read from the table to get the probability at the end. Okay. So now we have a look of part 2. Okay, part 2 is saying that maybe I should use the black color for part 2. Okay, part 2, the probability that the mean weight, right? So the sample mean of a random sample of n pebbles is less than 51.6 grams is 0.9332. Find the value of n. So now you're given that the sample mean distributions where the mean does not change, 48.5, and the variance 12.4 squared, but divided by sample size n. And the probability of this sample mean less than 51.6 is equals to 0.9332. All right. Okay. In order to answer the questions, we have to standardize it. So we minus the mean divided by square root of the variance. Okay. So in order to find out the z-score based on the probability given, we will refer to the bell-shaped curve here. So we can see that the directions we want is less than. So we are looking at the area towards the left-hand side from a probability of 0.9332. Means it has to start from here and all the way to the left with an area which is the probability 0.9332. And that is the z-score. 51.6 minus 48.5. 3.1. 3.1 over 12.4 over square root n. All right. So now we try to read from the table below. When the probability is 0.9332. Do we have 9332 exactly? Yes. Hence, the corresponding z-score 1.5 and 0. So we refer back to here. Hence, for a z-score of 3.1 divided by 12.4 over square root n, this z-score is 1.5. And then we can calculate out the value of n. Okay, taking 3.1 divided by 1.5. Then taking 12.4 divided by this value and square it. So the sample size is going to be 36. All right. So for this question, you are given the probability and you have to find out the corresponding sample size based on the probability given. And the answer found to be 36. Okay, so that is how we answer the question part 2. All right, now let's see the next questions. Okay, is a question from variant 7.3, October, November 2015, question 1. It is known that the number, capital N, of words contained in the leading article each day in a certain newspaper can be modeled by a normal distribution with mean 352 and the variance 29. A researcher takes a random sample of 10 leading articles and finds the sample mean. All right, we are looking at sample mean given as n bar of n. Part 1. State the distributions of n bar giving the values of any parameters. So, given by the questions, the capital N, the word contain, right, in the leading article, it follows a normal distribution with the mean 352 and the variance 29. Hence, the sample mean, the n bar, is going to be normal distribution as well with the mean 352, but the variance will be divided by the sample size, a random sample of 10 divided by 10. All right. So the question asks you to state the distributions. So when I label the n bar follows capital N here, means I have stated that this is a normal distribution. Or you can put at the side normal distributions. And the values of any parameters is referring to the mean. For this is going to be 352, has to be the same, but the variance will be divided by the sample size here. All right, so these are the parameters, the mean and the variance. So that will be the part 1. Now, part 2, straightforward, asking you to find the probability of n bar greater than 352, or it's a 354. So, since it follows a normal distribution, we must find out the standardized value, z-score. So taking 354 minus 352 divided by square root of 29 over 10. Okay, let's find out this z-score value. So the z-score up to 3 decimal places, 1.174. All right, refer to the bell-shaped curve. 1.174 greater than, so it's looking at this region. So similar to the previous questions, when we read from the table, they will always give you the area in the bigger region towards the left. So in order to get the smaller regions that shaded in blue, I have to take 1 minus the probability obtained from the table. So now we look at the extractions from the table, then read the z-score 1.1. 1.1 here, 7 here, and 4. Okay, 1.1, 7, and 4. Right, this one. So we can see the probability is X790 and 8. So it's going to be X798. So that is the probability 0.8798. And finally, take 1 minus it. So the answer, the probability found is going to be 0.1202. Round off to 3 SF, 120. All right, so the answer for part 2, probability found. And you can see the same keyword, the sample mean. All right, when it mentioned about sample mean, that's where we use the sample mean distributions, and it follows a normal distributions. Okay, so that's all for this lessons. Please subscribe to the channel and like these lessons. I'll see you in the next. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.